We are using basswood to produce the standard plane of the robot, including a section that juts down to hold the sensors in the front. Standard wheels with DC electric motors on either side, with some clamps to hold the motors so they don't move anywhere. And these wheels are very stable and they stay straight here. We had to use a spacer to get the center ball wheel at the exact correct position, and we used little blocks of wood. For each of the sensors, we determined this was a good spacing for them. We designed a header system where the sensors were properly soldered so that we got the signal lines that we needed from them, and did all of the resistances and data communication back to this board here. So all we send back is a single power, a single ground, and the signal lines that go directly to the PIC. So all the information and all the processing for the sensors is right here, saving room on the breadboard. For the breadboard, we just simply glued it right to the top of the robot itself. And this general design works very, very well.
Alright, so the PIC circuit involved with this, you have the sensors. There's 3 sensors. The light from the diode shines down onto the tape, reflects back. If it sees it, then it dumps. You have a logic low, or rather, it's active low. So basically, when there's no light here, it's going to be 5 volts into the PIC. When there's light, it brings it down to low. And so for each one of them, which we'll be going over later, will determine which motor is set to drive forward. If it's set to power these, positive here, negative here, then it's to drive forward. If you flip it, it's in reverse. And that determines which way, if you're going to turn left, if I'm going to turn right, or if we need to reverse to find the white tape again. Later on, another PIC will be added to add sensors for the wheel, but that's the next part of the project.
Then we have to determine the logic for the sensors and when we need to turn. As you can see here, once the sensors only register one particular side, whether it be the right or the left, that's when we're going to need to turn. So when the left sensor is reading the line, and the black here being no line, we're going to need to turn left. When the right sensor is reading the line, we're going to have to turn right. Otherwise, we're going to want to make sure that we go forward for all the other cases. However, if we go too far and we have no line read at all, if we're not picking up any type of sense, the sensors aren't picking up any reflection, then we're going to need to make sure that we go in reverse. And that's the logic that we used to get our robot to follow the line.
Hands, everybody, and everybody clap your hand. We land a